Welcome to 2 plus 2 equals cabbage. In this video, we're going to answer the question, how do I create a Windows instance in AWS with Terraform? And to do that, we're going to look at some of the requirements just to get Terraform working. If you haven't already created credentials in AWS to publish with Terraform, there's a link here and in the description where you can go to the video to see how we did that. Beyond that, we'll talk some more about the AWS prerequisites, how things work over there. We'll look at the networking, security, and things, and we're just deploying a Windows instance for the fun of it, just to see how it works and see how easy it is. Let's figure it out together. Okay, before we get into looking at the AWS console or looking at our Terraform structure, let's take a look first at the GitHub page, where you can find all of the sample code that we'll be working on in our projects. There are several different sections and separate repositories for AWS, Azure, GCP, OCI, and we'll have many different projects in there that we'll be working on. Today, we'll be focusing on the AWS base project, which will allow us to deploy a Windows instance into AWS. So if we come over here in GitHub, we'll just go to the AWS base repository. You can clone this to your local workstation, download it however you need to get the files down to your work environment. And we'll be jumping off from here. I'll switch over to view a lot of these files within VS Code, just because I like the way it looks there. It's a little bit easier to read. But this will be a resource for you throughout the process of deploying this. The README should be pretty inclusive of everything you need to look at from a step-by-step perspective. One thing I'll point out here is the structure of how I generally create my Terraform deployments. I try to keep them as modular as possible. So I've got separate files for separate pieces. And that way it also makes it easier to build on to these projects in the future if I wanted to add some more features. Those features can be compartmentalized into an individual file. So if I want to add them, I can just add the file. If I want to take them off, I just remove the file. So that's what we'll be doing. We're going to switch over to look at the Terraform construction within VS Code in a moment, and then we'll move on from there. Well, here we are now in VS Code, where we can take a look at what we've got for our Terraform configuration files. We're looking just at the Terraform AWS base. You should be able to pick this up from the GitHub that we shared a little bit earlier. And now we're just going to go through, not in terrible detail because you can look through the files on your own, but I'll just highlight some things and characteristics about the way I create the Terraform deployments, just to hopefully make it make sense. Like I mentioned earlier, I do like to keep things a little modularized, so I can always add things and remove them, and everything is in its own little file. So if I want to add something, I can create a new file, or if I want to take something off, I can just delete a file. But the basic structure we need for Terraform to begin with, we need to have our main Terraform provider information, which is here that I've put it in the main.tf. Nothing fancy here, very basic stuff. And then the next one is the AWS provider, where we're basically creating the parameters to connect to AWS. These are the required pieces that we need. We need the access key, secret key, and region. And these are all variableized. So we're actually pulling these from the terraform.tfrs file, which we'll look at in a minute. And if you watch the video where we created the accounts for AWS and created the access key and secret key, that video goes into detail on where we got those from and where we put those. But this is where they end up. We've got the locals.tf. This is where I specify the local variables. I generally use this for establishing naming conventions. So for objects that we create within the cloud environment, I try to adhere to a naming convention so things make sense when I'm looking at them in the AWS console. We only have a few things here. As we build out more complex environments, we'll have more items in here, but this is the basics for what we're working on today. I've got AWS networking, which this will include the basic networking structure for my AWS environment for this project, including the VPC, where we specify the subnet that we're using for the entire VPC network. And for reference overall for the different projects that I'll be doing through AWS, Azure, OCI, and GCP, I do try to keep the the IP address is unique. So when it comes time to do cross connectivity between the environments, which we will do in future videos, everyone's got their own separate subnets. So for example, the second octet for AWS here we see is 3. So I'll start with 0, 1, 2, 3, 4 for other cloud environments. This one we're using 3. In this case, we've got a /16 allocated for the VPC, and then we're only using one subnet within this environment, and that's the subnet that the Windows instance will sit on, and it's 10.3.1, and it's /24. Certainly much bigger than we would actually need for this use case, but simple enough. In a real environment, we might be a little more judicious about how we allocate IPs, but we're just testing here, so having a little bit of fun. Next, we've got all of our routing specified in a routing-static.tf. If I were doing something like BGP, I would have a different file for this, and I would keep it modularized so I could swap them in and out, making it nice and easy. In this case, we're not doing an awful lot, but I do like to specify a route table for every subnet that I create, because I do want to take special control over where traffic flows. One thing about the cloud environments is they make it very easy to route traffic, and sometimes you'll be able to route traffic in ways that might be very simple, and it might get you the access you need for the internet or things like that, but it might not be how you want to securely control that traffic. So I always like to specify route tables for subnets so I know exactly where the traffic is going. I've got the windows.tf here, which creates the Windows instance. It specifies for AWS, you need an AMI, which is basically the image that it uses to create the Windows instance, the instance type or size. All the cloud providers have different terminology for what they call those, but this T3.medium, for example, gives you compute resources, and that tells you the size of the memory and the CPU and things like that. One other little bit of information I wanted to share is, in this instance, we need to make sure that we're turning off the Windows firewall on deployment, because in our case, we want to be able to RDP into that instance from our public IP wherever we are deploying this from. So in order to do that, we want to make sure that the Windows firewall in the instance is turned off. Otherwise, we won't be able to RDP to it, and we'd have significant challenges in just trying to access the instance at all. Other things here, we're doing a little bit of output. We'll see at the end. I like to output important things during the Terraform Apply, just because it gives me the IP addresses I might need to have at my fingertips right on my screen. I don't need to go hunting for them or try to remember them, and we'll see those show up, and I'll point them out again once we get ready to actually apply. Security group. I do like to specify, much like the routing, I like to specify the security group so I know exactly what is and is not allowed and not depending on defaults. So I've got pretty tight control on this instance access. So I'm only allowing access via RDP, which is TCP 3389, from my public IP address, which we'll see specified in the terraform.tf vars file. And then on the way out, we're just saying this instance can go wherever it wants, basically. We're not providing any controls on where it can go. And then variables, we specify a lot of the things in the different files, so we can reference them as variables. And then the Terraform TFR's template file. This is going to be included with all the projects that are in the GitHub. It gives you a sample of everything we need for this particular project, and also provides comments on what each thing is. And we'll take this and populate it in the terraform.tfrs file as we move forward. But this is where the template is. So it gives you a guide for what's needed and what things actually are. And going back even to all the other TF files, we've gone through and put in comments on every line where it made sense. So every line is pretty well referenced to know why there's a line in the file throughout the whole collection of files. Just helps to explain what things are. So it's a good learning point where you can see what things are and why they're there. So going on to the terraform.tfrs file, this is where the actual data needs to go for when we're going to deploy. I've made some extra comments on the side here just to identify things that were absolutely required for what we're deploying. In this case, we need the region, the access key, and the secret key. And we noticed we had those referenced back in the AWS provider.tf. So this is where they're coming from. They're coming from the terraform.ts vars file. And these things that are marked required in this file, they mean something specifically. So we need to have, the region has to be an actual region. So there's special syntax that needs to be used there. So we want to be careful that we're using the correct name. The access key is an actual key name from our tenant, and the secret key is an actual secret key that comes from the tenant. We can't make those things up. They have to be actually coming from the tenant. The public IP, this is the IP address of where you sit when you're deploying this. So when you want to go and access the instance that we're going to deploy with RDP, this is the source IP that you need to be coming from. So that has to be accurate. And if you don't know your source IP before you even start this, you can just open up a web browser, go to ipchicken.com, and it'll tell you your IP address. The key name here, this references the key we created in AWS, which is used for example, in this scenario, it'll be used to retrieve the default administrator password from the AWS console. And this is something we created during our setup of the account. And that should be pretty much it there. These two items that are marked with these comments, just a name. So all this means is there's nothing saying these need to say a certain thing. I've got these in here to help me identify what things are and which environment they're in. If we went back to our locals.tf here for a minute, we see we've got, for example, the VPC name. So when I create the VPC, and we'll bounce over to where that's created in a second, we're naming it with a certain naming convention. And the environment name and the location are being pulled from the terraform.tf vars file, where I'm saying, in my case, my environment is called Cabbage and my location is US East. And that's more just to help me identify where things are. Note the difference in naming. It's not the same exact name as the region, where the region actually needs to exist and it needs to be named something like US-East-1. For my visual representation in the console, I'm fine just looking at it saying US East, but you could put whatever you want there for that. And then where that gets referenced back, looking at the locals, when we create the VPC name, these variables are used within the AWS-networking file, where we're saying, here's my local VPC name. So it's taking what's in the locals.tf, putting it together. So VPC dash environment name dash location dash, and then in here, we're just adding on, we're taking that whole thing and we're adding on a suffix that helps me understand that this means this is basically looking at the CIDR block up here, 10.3.0.0/16. So this is 10.3.0.0/16. So, and that's just for my identification purposes, but I wanted to explain that because you'll look at that and wonder what that is. And that's just the way I represent it in my own little pea brain, so I can keep track of things. So once we've got our files in place and ready to go, we're working at a terminal here, and on this workstation, I've already got Terraform installed. So the first thing we want to do is, from the folder where Terraform is located, we're going to do Terraform Init. And this will take a minute or two just to go and kind of set the stage for deploying with Terraform. It's going to make sure everything matches up and the environment is prepared. It'll install the provider if it needs it. And then once it's finished, we can move on to the next step. Okay, that finished in just a couple of minutes. So now we're back, and after we've done Terraform Init, we're going to do Terraform Plan. And this basically goes through the structure of the project, all the files, and analyzes what it will do. And if it detects any errors, it'll report back and tell us if there are any errors. I don't expect any in this case, so we'll run Terraform Plan. And this shouldn't take very long to run. It's just going through, analyzing, and then we can go back and look at the output of what the Terraform plan did. In summary, it basically said it found 8 things that it's going to add, no changes, no destroys because there's nothing there yet. And we can scroll up and we can look at all the plus signs mean, the green pluses mean it's going to add something. If there was something being removed, it will be a red minus sign. But this goes through every file and everything, and it doesn't matter, the number of files, as long as there's a TF file in the working folder, it'll go through and read every one and do everything that's in those files. If there are any conflicts or duplications, it'll tell you in this output so you can fix it. But this one's pretty straightforward. And then at the very end, once it would apply, it would actually tell us these things that I had entered in for outputs. So it would tell me the VM private IP and the VM public IP. But with that being done, we're ready to apply. So all we need to do now is do Terraform Apply. And I'm only doing Terraform Apply for illustration purposes. Normally I would do the auto approve just to save one, a little bit of extra typing, but Terraform Apply is doing everything that Terraform Plan did, but then it's going to actually apply it to your AWS environment. In this case, since I didn't type auto approve, it's asking me to say, yes, do you want to apply this? So I'll just type yes and hit apply or hit enter. And this will go through and deploy. This deployment should be pretty quick. It won't take but a minute. And it'll be ready to go once it's done. Okay, that finished. And as we can see, it tells us the apply was complete. We deployed 8 resources. We didn't change or destroy anything. And then we've got the actual outputs down below for what was deployed. And the things that I need specifically are the VM private IP, which incidentally doesn't really mean anything to us right now. We don't really need to know that in this scenario because we don't need to reference it for anything else. We're not deploying firewalls or anything or any other workloads. The main thing that we need to be looking for is the VM public IP, and this is the IP that we will use to RDP into that Windows instance when we're ready. So we've done what we need to do here on the Terraform side in VS Code. We've deployed, so our configuration is out there. Once we've finished, when we're dealing with things like Windows instances or anything like that, they do need boot up time like anything else. So we may want to wait a minute or two before we try to do our RDP just to make sure that that instance is booted. But we'll also jump over to the AWS console just to see what things look like once they're deployed before we even try to do an RDP session. After we've deployed with Terraform, we can come into the AWS console where we can look at everything that we deployed. There's a few different places that we'll look. First, let's take a look at the networking that we created, and we'll start off with the VPC. That'll give us access to everything that we want to see. We can just search up here if we don't have a link and go to VPC. And here we do see a summary on this page, which is handy, especially after you've maybe gone in and destroyed your deployment and you want to make sure everything's cleaned up. You can look here to see where things might exist that you might not have expected. Things like subnets or route tables. You can see that we've got a couple of here. So the first thing we'll do is we'll look at the VPCs. This is the one that we just created with Terraform. We can see the CIDR of the entire VPC 10.3. And then within the VPC, if we needed to go in and make some adjustments, we can see some of the connections in the resource maps where we've got the VPC itself. Right now, we've only got a single subnet, and we've got some route tables that are specified, and then an internet gateway. This is all basic stuff. Good place to go and look around just to see where things are, but everything individually can be found in the menu. So we'll go and look at the subnet. We've only got the one subnet we created. And as we see here, the naming convention helps out because we can see, oh, this is a subnet. The prefix says SNet, so in my mind, that tells me it's a subnet. We've got route tables. Here we use the prefix of RT to tell us it's a route table. The internet gateway, which allows everything to get to the internet, IGW, and things like that. So everything's there. The next place we'll go look at is the instance that we deployed. So we'll go into EC2 to look at instances. And over here, we've got the instances menu. And we can see we've got our VM Windows. So we're running a Windows VM just for testing. Tells us all the information we might need here. Clicking into it, we can see things like the public IP address. Now, remember from when we were looking at VS Code, we were outputting that within Terraform. But if we needed to find it, this is another way that we could find it. And then one other thing that we'll need to access from this interface is the administrator password. By default, a Windows administrator password is set, and we need to come in here to retrieve it. So we'll go under the Actions menu, we'll go to Security, and we'll go to Get Windows Password. And this is where we need to upload our key that we had created when we created the account credentials to access AWS. And the Terraform key name is something that we specified in our terraform.tfrs file. So that's the key that we need to use in order to download the temporary Windows password. So I'm going to upload my private key file. You can either go find the file or you can paste the contents into the box. We'll go find the file. And then we can just click decrypt password. And right here on the screen, it shows us the password. We'll take this and copy it off to a text file so we can have it handy. And by default, the user name will be administrator. So that's what we'll use as the login name. So now we've seen where everything ends up being published within the AWS console. Now we'll step out into an RDP session and we'll try to log into the Windows instance and see how it works. All right, we're ready to log in to our remote desktop connection using Windows as the client. So we'll just open up a remote desktop connection. The IP address we're going to use is what we either gathered from the AWS console or from the output from the Terraform output in VS Code. And we'll just click connect. And here it's prompting us for that password that we got from the console. So we'll just grab that, paste it in there, and then click OK. And we're logging in. So pretty quick, we're logged into the Windows session, and we can just make sure the internet works. Open up Microsoft Edge. Go to our favorite GitHub page, make sure that works, and we're good. So now we've gone through the process of downloading our Terraform files, doing our initialization. We've applied our configuration. We've checked everything out in the AWS console to make sure it worked. We've RDP'd into our Windows instance to make sure that worked, and we can even get to the internet from within that environment. The next and final thing we really need to do will be to clean up our mess. We don't want to pay for things that we're not going to be using, so we want to make sure we go through and remove what we deployed into AWS so we don't get charged for things that may just be sitting there idle. So we're going to switch back over to VS Code where we can destroy our configuration. Well, we've had our fun deploying into AWS, but now we've got to tear it all down because we're cheap and we don't want to spend money. So all we need to do here is come back to VS Code, and very simple command. We did apply to put it up there. We're going to do destroy to bring it down. And like before, I'm just doing Terraform deploy to show you the interface. It'll ask me to say yes. Normally, if I was doing this, I would put the auto approve tag in there. But we'll just let this go and ask us, do we want to destroy? And as you can see, now we've got a bunch of red minus signs. So it's going to take away everything that it created. And we'll just type yes here and let it go. And it won't take long, and it'll just remove everything that we put into AWS. And that's one of the great things about Terraform. You can put things up very quickly and you can take them down very quickly. If you were to do this in the AWS console manually, it would take a good amount of time to go through and create each individual thing you needed to create. And then once you're all done, there's not just a single button to go and remove everything you created within the console. You've got to go and remove things more or less one at a time, because it won't let you delete things in the console if there are dependencies that rely on the thing you're trying to delete. So it's a little bit more complicated to add and delete things within the console. This is where Terraform really shines, because all I did was I typed Terraform Destroy, and it went through and it took everything that it deployed and it destroyed it. Very simple. So that's it for the AWS base deployment with Terraform. In the future, we'll do more projects with AWS and Terraform. We'll do things like create IPsec tunnels between other cloud providers. We'll do different types of routing techniques. We'll do some Palo Alto firewalls. So there's a lot more to come. Stay tuned, and we'll be having a lot more fun with AWS and Terraform. Thanks for visiting 2 + 2 = Cabbage. If you found this video useful, like and subscribe to show me there are people out there who would like to see more of this content.